What we're going to do is play with what are known as turtle graphics. The idea behind turtle graphics is back before everybody had personal computers. You make a mechanical turtle that had wheels and a pin, and you could program it. You could tell it to go forward 2 feet and then turn right 90 degrees, go forward 2 feet, turn right 90 degrees. Or, you could make them go in sharper angles and draw a star, or you could tell it to do a circle of a certain radius, whatever. So, of course, it's much easier, if you have one on screen rather than having one, run around on the floor. So that's what we're going to do. So go ahead and load up idle. And by the way, I hope nobody had any significant problems with the earthquake. Yeah. I had a weird side effect. We have a wooden wind-up clock that hasn't worked in 2 decades, and after the earthquake it started chiming and it started working again. So I guess all the clock needed to be fixed was a darn good shaking. So chapter 3 of the How to Think Like a Computer Scientist has some code for using the turtles. So if I can dock this over to the side and get this over here, File, New, and whatever you do, don't call your program turtle, and whatever you really do, don't save it into the Python code directory with that name, or else turtles never work again. So save it to desktop or wherever you normally save your stuff, and let's call this one, I don't know, what's the name of the Ninja Turtles? Leonardo. We're going to call this one Leo.py. So the turtle graphics are not built in to Python. It's a library that's been added to it. So we have to use the import keyword to bring that library in. Import turtle. And then there's a few lines here that we type just to set things up. We're going to type WN, which stands for window, is equal to turtle.screen, and the S in screen is capitalized. And these are parentheses, not curly braces or square brackets. And now let's create a turtle called Leo. So we're going to say Leo is equal to turtle.capital turtle, parentheses in parentheses. And I'm putting spaces around the dots, but you don't have to do that, just to make it real clear for those of y'all in the 5th row. Alright, so let's draw a square. Leo, go forward 100 pixels. I feel like I'm talking to Siri or Hey Google. Leo, go left, turn 90 degrees. Remove the semicolons. I'm not supposed to be putting semicolons. Wrong language.
And it does need to be, it has to be on the same line, right?
What has to be on the same line?
Once you put in the colon, oh, did you mean to take the colon away?
Correct. Correct. The colons are a C++ Java thing. And sometimes I do them just because I teach C++ and Java as well. So to draw a square, it needs 4 sides. So far we've drawn side 1. Here I go with my Java. Now that's side 2. Yes, sir? I thought I heard a question. guess I didn't. Well, we could be copying and pasting, but we're adding a little bit more than what's over here. And yeah, you're right. Why am I not just copying and pasting those two lines? That's pretty ignorant. Thanks. Thanks for making me feel like a fool. Okay, so, and then I could make a final turn left, and then I would be facing the way I was originally. So, I'll do that. There we go. And then I'm going to do this WN period main loop. All that does is keep the window open until it's closed.
So, like, you know when we're making the interest, or when we're doing that math homework?
Yeah.
If we would put that at the end, would it have kept it open?
No, because that is part of the turtle library. It keeps the turtle window open, not the normal window open. Good question. And there we go. It draws a square. Just a second. I'm trying to remember something. Yeah, I'll walk around and come help. Okay, if you do get this working, change it to draw a triangle. If you're going to draw a triangle, though, you only have 3 sides rather than 4. And what are the angle for a triangle? 60 would make a hexagon, I think. The way you figure out the angles is how many are 4 times 90. That's 360. So it's 360 divided by the number of sides. So 120 would make an equilateral triangle. So change your angles to 120 and then only draw 3 lines rather than 4, and you have a triangle.
I got it.
Oh, you got it? Okay, good deal. Good deal. Good deal. Alrighty. Importer. Change that to import. Yeah. Backspace 3 here. Get rid of that. Yeah, there we go. Alright, now let's look. Screen has to be capitalized. Not that there's no reason when you capitalize and when you don't, then I might agree. Okay, we've got one line going. Let's go see where it is. Ah, typo. Oh, cool. We have a hexagon over here. We're upping our game. That's cool. Triangle and a square. Word with an A. Yeah. Well, whatever. Computers need to do what I mean. Take out that main loop because it's paused in there. That's why it's not drawing a triangle. Cool deal. Got it. All right.
I'm still kind of confused.
Wait a minute, you had it going.
Well, I had a square, but I didn't have a triangle. I didn't know how to make the
Triangle, you're going to go forward however many far you want, but instead of turning 90 degrees, you're going to turn 120 degrees each time. So just make it forward 100, left 120. forward 100, left 120. Forward 100, left 120. So yeah, I'm going to tack on a triangle to mine. I'm going to do it above the main loop, because if I put it below the main loop, then the program pauses there and I don't get to see my triangle. Let's be smart and copy paste this time. And I'm going to put comments here that indicate that this is a side one of a triangle rather than a square. T1, T2, T3. We can also set the colors, and we can also fill the shapes that we draw. Like after you draw a square, you could fill it. We will add some code to do that. So to change the color of the turtle, you use the .color command. So now that I've got a square being drawn here, I'm going to come and change the color of it before it draws a triangle. Now if you erase the code or you started a new one, that's okay. But above your first line of your triangle, do Leo.color, parentheses, quote, red, end quote, like that. Now when it draws a triangle, it should be red. And what if we wanted to fill in that triangle? Well, what we're going to do then is, after we set the color of it, we're going to do Leo.beginFill, parentheses, end parentheses. And then after the last part of the triangle, we're going to add Leo.endFill, parentheses, end parentheses. And it blows up. Alrighty, let's figure out how to really do it. My mistake. Oh, it's begin underscore fill and end underscore fill. I'm sorry, pardon me?
Do you put the color afterward too, or no? When it says begin fill.
I don't know what would happen if you changed the color of it after the fill. So I put the color before it.
Okay.
Well, we could try it. What happens if we change the color to red after we fill it? Or black? This is an experiment, don't. Apparently I can't type.
Oh.
Yeah, okay. So apparently any time before, what if we did this right before the line end fill? Would it draw it in red but then fill it in black? Huh, kind of cool.
That's cool.
I'm going to take that out though, but that's cool. So in this case, Leo is a special kind of variable called an object. And as you go on and you take more programming classes, you'll learn about object-oriented programming. In their sample code here, the object is named Alex. Why is it an object? It's more complicated than just a number. A turtle not only has a number, but it has a direction in which it's heading, and it has a line thickness. We could change the thickness of the line. It has a color. So
There's properties of the object in question.
yeah, all the properties of it are bound up into one object. And you can get 2 or 3 or 4 or 100 turtles on the screen at the same time, each one of those being a different object. Let's speed the turtle up and change the thickness of the pen. Way up here, right where we create the turtle to begin with, do Leo dot pen size. Let's make that a thicker pen. It defaults to being a thickness of 1. And let's speed it up to max. Leo dot speed 0 means draw it as fast as possible with no delay. I don't know what the default is, but 0 you will see is a lot faster.
Is pen size, does it need to be like underscoring?
No. I don't know why in some places you do use the numbers underscore and some you don't. Just a sec, I'll be right there.
I got it.
Oh, good.
Alrighty, so that's one turtle program. Don't know if I gave everybody a chance to type it. We're going to make another one now that instead of doing this, we'll make it do something else. So I'm going to copy all of these lines from this program and paste them into a new one. I want the import. I want that dot screen, that dot turtle, that dot pen size, and that dot speed. So I'm going to copy those 5 lines of code. I highlight them all. I choose copy. And then let's do file new. Let's just save this one as Leo 2. Alright, so this time we're going to draw a circle of radius 100. And then we're going to turn 90 degrees. Let's turn right rather than left. And we're going to draw another circle. And then turn right 90 degrees again, draw a third circle, and then draw a fourth circle. When you use the color command, you can specify 2 colors rather than just 1. If you specify 2 colors, one of them is the pen and one of them is the fill. So before I draw my first circle, I'm going to do Leo dot color, and I want green lines with a yellow fill. And that didn't work because I don't have any begin and end fill commands. I would have to put a begin, fill, and an end fill before and after every circle. And that seems like a lot of trouble, so I'm not going to bother.
Is that if you want to make all of the circles different colors?
Yeah, we could change. Yeah, we would have to fill them, each one individually. It would look like this, but I'm not going to do them all. I guess it wouldn't take that much time. But begin underscore fill like that, and then Leo dot end underscore fill, and then now I'm going to copy that and paste that 4 times.
So the first one is the pin color, and the second one is the fill color.
Right.
Okay.
Right.
I got it. Okay. Cool.
Yeah, cool.
Oh, I
I didn't
got
think it-
my word for that. I was gonna try.
You're going to
something else.
mess with that stuff. Okay, cool. Alrighty, let's use a loop now to draw kind of a flowery looking shape. So I'm going to take, again, these top 5 lines from import turtle all the way down to the speed command, and do new file. Let's call this one Leo 3, save as Leo 3, and we're going to use a loop. This is going to be a little bit more complicated. How many circles do we want? Num circles is equal to 4. So the angle is equal to 360 divided by 4. And now we're going to use a command that we haven't done yet. Yeah, we have. So x is equal to 1. That's going to be our counter. While x is less than or equal to the num circles, I guess I could just name that num to make it easier to type, but colon. Leo.circle with the width of 100. Heck, let's make it larger, 200. And then Leo dot right or left, our angle. And last time we forgot to add that main loop thing or whatever. Let's look at that. Yeah, main loop. We tack that on. Doesn't seem necessary, but. Ooh, 200 was a little bit too big. And also it seems stuck and going forever, and that's because I forgot to increase x. A while loop means keep repeating the code as long as this condition is true. But since we're never increasing x, it's never false. So I'm going to do x is equal to x plus 1. And I'm going to change the width of the circles from 200 back down to 100. Alright, that's a 4-sider. Let's change it to 16 circles. Oh, and this should not be divided by 4. It should be divided by the number of circles. Alright, so now I've changed that line, and I've changed that line. I'm putting little comments here just to note that these lines had to be changed since the last version of it. There. change the pin size to 1 and make the number of circles really large, like, 45. Don't know if kids anymore ever get to play with spirographs, but that's what that kind of reminds me of. If we don't like seeing the little shape of the turtle as it draws, you can issue a hide turtle command. So maybe under the speed, I'm going to do leo.hide turtle. And we should be able to change the background color of the window as well. Probably shows that on that Think Like a Computer Scientist page. Let's go look. Here he's filled the window with a background color of light green. So we can do that. The command is called BGcolor. So up here under windows.screen, maybe above where we changed the pen size, wn.bgcolor. And blue will be hard to see. Yellow, that'll be blinding. And don't put a space in front of yellow like I just did. There we go. If you're curious about the colors that you can use, I'll post a link to a web page for it. Okay, if you go to the main page of our D2L section, if you go to Course Home, there's a link to a web page. Turtle colors. These are all the colors you can use. You can get more control if you specify RGB by numbers, but this is a lot of colors. like the fact that there's 100 different shades of gray. That's even more than that book. Wheat. Wheat is a better shade of yellow. So I'm going to go back over here and change BGcolor from yellow to wheat. W-H-E-A-T. I don't know, that's kind of a nasty beige, but whatever.
But I made it move forward this way so
Yeah.
it turns, so it kept going in a big circle.
If you want to not make it draw a line as it moves, you can use pin up and pin down. So,
Because I put like Leo forward instead of.
so you could do Leo dot, pin up, pin up,
Like so.
parentheses, in parentheses. Yeah, nothing between the parentheses, and then underneath is pin down. Next line, start. Yeah, you'll have to erase all of that and do Leo dot pin down.
Oh, okay.
Yeah.
Oh, okay.
is to have it. Whoa. How many turtles? How many circles is that? 100. That is cool looking. One more useful command is to lift the pin. You can do that with pin up, and then to lower the pin down. If you do anything while the pin is up, it doesn't leave a trail. Why would you do that? Well, you might want to start something in place different than right in the center. You might want to move up 100 pixels before we started drawing. So right here, after my hide turtle, I'm going to make it turn. I'm going to set the heading of it, and then I'm going to go up 100 pixels, but I want the pin up when I do that. So, right after I've hidden the turtle, Leo dot pin, P-E-N-U-P, no underscores. That lifts the pin. Now let's set the heading, the whole word, set and then heading, H-E-A-D-I-N-G. And we're going to go 90 degrees. That's actually not, on a compass, 0 is due north, but in turtles, 90 is due north. And we're going to go forward 100 pixels, and then we're going to lower our pin. So, it went up. You can't really tell, but if I hadn't gone forward, it drew it in a different place. I'm going to make it go 200, and it's almost going to be off the window. So you see what I mean? I keep notching it up. It's going off the window. Let's go up forward 300 rather than 200. But it didn't leave a line on the way there. So by doing pin up, it didn't draw while it moved. If I commented this out, it would leave a line as it drew. Like that. We'd see that line going up. That is almost all of the commands that we are interested in. There's also set X and set Y. So if you just want to completely set it in a different part of the screen, let's change this set heading and this forward. I'm going to delete those two lines, and in between pin up and pin down, I'm going to do Leo.setX, and I want to move it to the lower corner of the screen. So X is left to right, and Y is up and down. So I'm going to set X to -100, or maybe even -200, and Leo.setY to -200. And then Leo.pin down. I already have that. I didn't need to do that again. So it's lifting the pin, and then it's jumping down here to draw its circle. Now the next time we do this, we're going to work at modularizing this stuff, so that with a single command you could draw that entire spirograph. And with a single command you could relocate it on the screen. But this is probably about enough fun for one day. I don't really like going 100 because that makes it where we can't see the whole thing. I'm just going to change that to 100, 100. We could change the width of the screen, I bet. Let's see how we do that.
Is there like a
Screen size.
is there like the syntax page for the turtle input thing? Like, say all the commands.
Yeah, there is. We'll link to that. Okay. So after we create the turtle, before we set its background color, let's do. I've already forgotten what it was. screen size. Let's see if this works. Screen size, and I want my thing to be 1000 by 1000. Now the window should be a square, but it's not. It could be resized to be a square. Okay, screen size isn't working. I'm going to just delete that for now. Okay, let's go find the documentation for all the different turtle commands. Python 3 turtle. Here we go. We'll post this in the news along with those colors. Turtle documentation. Okay, so if you want to play with this more, and we will be using turtles again, then the documentation for all the different commands that turtles support is now posted in the news. Alright, let's create our extra credit Dropbox. Alright guys, if you go to the Dropbox, you'll see an in-class called Bonus Turtles. Go ahead and upload your Leo scripts, however many you created. I did 3, so I would upload 3.